Hello, my name is Mingyuku, and this is a part 2 video to the Arduino swim clock video series. In this video, I will show the required materials for the circuit and how to wire everything up. Let's get started with the materials required for this circuit. You will first need a bunch of jumper wires. I recommend getting a wire kit, such as the image here, as it comes with solid colored wires that can be later soldered for permanent use. In addition, you will also need an Arduino Mega for processing power and the USB-B cable to power the Arduino. For soldering, you need a solder board, such as the one offered by Adafruit. For the displays, we are using two 64mm by 32mm 5mm pitch LED matrix displays. This is offered on Adafruit's website and retails for $50 each. These displays are around 10 to 11 inches tall and offer the size that I want. Finally, the Arduino itself cannot power two displays, so I recommend you need to get a 5-volt supply with at least 4 amps. Now let's get on to the wiring. You can originally wire this on a temporary breadboard, such as the one on the left, for testing. However, I recommend eventually moving on to a solid board, as it can be used for long-term usage. Now, it is key that you have the pins as shown on the right image over here, the tiny pins, as that is what you're going to be plugging in the ribbon cable that came with the display into. The wiring aspect might sound confusing, but I will walk through the process. The left image shows how the input will look like on the back of the display board. The right image shows how the ribbon cable will look. Notice how the ribbon cable, the inputs are reversed. Make sure you pay attention to where the notch on the ribbon cable is, as that will serve as a guide for wiring. Therefore, when you wire, I suggest that you copy the diagram on the left, as it will be correctly represented when plugging in your ribbon cables. Before I start teaching the wiring process, I will explain what each pin functions as. The R1, G1, and B1 controls the RGB data to the top half of the display. The R2, G2, and B2 pins control the RGB data to the lower half of the display. Pins A, B, C, D control which rows of the display are lit. The lat wire controls the end of a row of the data sent. The OE wire controls the on and off function of the LEDs when moving down rows vertically. Finally, the CLK wire, or the clock, receives the arrival of each bit of data. Now normally, the Adafruit library does not support the usage of two displays linked to a single Arduino Mega. However, there is a way that you can modify the library and code in order to power two displays off of one Arduino. The trick is to send the same color signal to each display. Here's what I mean. In order to display two different digits on two different displays at the same time, we must send different color signals to each display. In the code, which we'll come back to in a later video, we will set the signal color as either red or blue. The red signal line is sent to the left display, and the blue signal line is sent to the right display. So, to be clear, you plug the red signal cable that comes out of Arduino digital pin 24 into the R1, G1, and B1 components. So the signal pin that comes out of the red plugs into all three R1, G1, and B1 signal pins. That way, when the display thinks that it is receiving green signal and blue signal in the G1 and B1 pins respectively, but in reality it is actually receiving the red signal. And this is on purpose, as all three components of the RGB pixel will be illuminated to be white, the brightest color. This is the same for the bottom half of the display, R2, G2, and B2 pins, where the R2 pin plugs into pin 27. This is also the same for the right display, but instead of using the red signal cable, you're using the blue signal cable. The blue signal cable for R1, G1, and B1 is pin 25, and the blue signal cable for R2, G2, B2 of the right display is pin 28. Pins A, B, C, and D are linked between both displays and plug into A0, Alpha 0, Alpha 1, Alpha 2, and Alpha 3 respectively. These are analog pins. The lat wire, OE wire, and the CLK clock wire are also linked between both displays and connected to pin 10, 9, 11 respectively. These are digital pins. Make sure to complete the ground wiring. With this, your wiring should be all complete. Feel free to skip back to my picture of the solder board if you need to confirm if your wiring is correct. If there are any problems with the display, please leave a comment down in the video. I will release another 2 videos later in the next 2 weeks. The first one will discuss how to code the display and modify the library to make the 2 displays work. The second and final video will discuss how to build the clock and get it to work. Thank you. See you next time.